Hi guys! Today we're going to consider a really cool trick how to easily find a derivative of the inverse function provided that you already know the derivative of the original function. So what I'm talking about is, for example, if you know the derivative of sine x, and we know that the derivative of sine x is, cosine x, then you can easily find the derivative of the arcsin x. And so arcsin is the inverse function of the sine function. And so I'm going to show you how to easily do this. And to do that, we're going to use the differential notation. So let's delete that for now. And so we're not going to use sine x prime actually. We're going to use the differential notation. So we know that this is cosine x. Okay, so another way to write this is d of sine x over dx is equal to cosine x, right? So this is just another way to denote the derivative. And now we're just gonna do a substitution for our variables. So we're gonna write let sine x is equal to t. And so if that holds true, then x is of course arcsine of t, because that's the inverse function, right? And now what about cosine? So we want to express cosine x in terms of t, and for that, we actually want to write it as a sine x, because we only have t as for sine x. So another way to write cosine x, as you probably know, is that cosine x is equal to square root of 1 minus sine x squared, right? Because sine x squared plus cosine x squared is equal to 1, right? So this is just another way to write it. And from this, we're actually going to be able to replace everything with t. So now let's just rewrite this whole thing. Use d of sine x over dx equals square root of 1 minus sine x squared. We're just going to rewrite the whole thing using t only. And so let's write it over here. So instead of d of sine x, we're going to write dt. We're going to write d of t, because sine x equals to t, right? Then on the bottom, it says d of x, but x is equal to arcsine t, so we're going to write d of arcsine t. d of arcsine t. And finally, that equals what? That equals the square root of 1 minus, and it says sine x squared, and we know that sine x is t, so we're just going to write t squared. Okay, great. And now the last step is we're just going to swap the numerator and the denominator, because, well, you'll see why. That's actually going to be our last step. So we just swap them, okay? We just swap them, and what we're going to get is d of arcsine t over dt. And so since we swap here, we also want to, this is like divided by 1, and we also swap here, right? So that the equation would still hold true. And that equals 1 over the square root of 1 minus t squared. So as you can see, and actually if you look closer, this is exactly the derivative of arcsine t. You see, d of arcsine t over dt is equal to 1 over square root of 1 minus t squared. And so this is the answer, okay? This is the answer. We found the derivative of arcsin t, or arcsin x, because like it doesn't matter which variable you use. So as you can see, there aren't that many steps, and we found it so easily. Now let's try with something else. Let's try one more, but this time we're gonna use, suppose we want to find ln x, right? ln x. So what is the derivative of ln x? Well, ln x is actually an inverse function of e to the x, as you might know. So we're going to use our knowledge of that variable, of that function. So we know that what's the derivative of e to the x? We know that the derivative of e to the x is actually equal e to the x, which is great. It's going to save us a lot of calculations. Now we're just going to do the same thing. We're gonna make some substitution. Specifically, we're gonna say that e to the x is equal to t. And so this is where the fun part begins. Then x is the power, right? It's the power that we need to raise e, to which we need to raise e in order to get t, right? So that's why x is actually equal to ln of t. Okay, so it means that they're inverse. And that's pretty much it. Then we just rewrite this thing here, okay? Then we just take this thing here and rewrite it, in terms of t. So instead of d e of x, we just write d of t, right? Because t is equal to e to the x. Now instead of dx, we write d of ln t, okay? I'm gonna write an arrow here. And now, instead of e to the x, we're gonna write t, right? So that's it. That's pretty much. And now, the last thing that we need to do is we're just gonna swap them like last time. So we're gonna swap them here and here. And what we're gonna get is d of ln t over dt is actually equal to 1 over t. And that's exactly as we know it. So, as you can see, it's really easy. And now let's consider the last one. Let's consider tangent. So, suppose you want to find the derivative of arctangent, okay? What's the derivative of arctangent? So you can easily find it if you know the derivative of tangent x. Suppose we know it. So the derivative, and let's write it, the derivative of tangent x is actually equal, dx is actually equal to 1 over cosine x squared. Now let's do the same thing. So we're going to say that tangent x is actually equal to t. Then t is equal to the inverse function of that, so it equals arctangent x. Yeah, wait, I wrote it wrong a little bit. X equals to arctangent of t. And now here's the interesting part. So you see on the right hand side we have 1 over cosine x squared. And that's a bit of a problem because, you know, if we because we wanna express this part in terms of t. So 1 over cosine x squared is actually not a good thing, but fortunately, there's this awesome formula. That says that 1 over cosine x squared is actually equal to 1 plus tangent x squared. So this is just a formula from the textbook. In case if you want to know, well, just Google it. It's really like well, okay, in case if you want to prove that, actually, well, you probably know sine x, sine squared of x plus cosine squared of x is equal to 1. You probably know this one. And so if you wanna, and so if you just imagine that you delete, if you divide each term by cosine. So imagine you just divide each term by cosine. So you got cosine squared x here, cosine squared x here, and cosine squared x here. So here you get tangent x squared, here you get 1, and here you get 1 over cosine squared x squared. Okay, so this is just a little proof. Anyway, so, and this is great because we have tangent, right? Sorry, I wrote tangent as tg, well, but this means tangent. Well, okay, not to confuse you, I'm gonna write it as, I'm gonna be consistent and try to write it as tangent x squared. Okay, now what I'm gonna do here is I'm just gonna rewrite the whole thing in terms of t. So we have d of tangent x, and we're gonna rewrite that as d of t, just as before. Now at the bottom we have d of x, and d of x is actually d of arctangent t. Okay, and on the right hand side we got 1 plus tangent x, right, squared. So we got 1 plus 1 plus and we know that tangent x is t, right? So it's just going to be t squared. Okay, and the last step is just to swap them around like we always do. So we're just going to divide by 1 and swap both sides. And so what we're going to get is d of arctangent t over dt is actually equal to 1 over 1 plus t squared. And that is the answer. That is the derivative of arctangent of t. So now you know why all those derivatives of inverse functions have 1 over something, because we swap this stuff all the time. So okay, so I guess that's pretty much it. Thanks for watching. I hope this can help you in the future.